Hello everyone, I'm Sam, a Huawei engineer. Today, I will be talking about how the FabricInsight cluster achieves high reliability. If the server is faulty after the FabricInsight cluster is set up, the Big Data Analytics service will be affected, increasing network O&M costs. FabricInsight uses various reliability mechanisms to ensure that services are not affected upon SPOF. FabricInsight servers are deployed in a cluster. Collector. You are advised to use two servers to form a collector cluster running in load balancing mode. In this way, if one server is faulty, the other server can take over collection services to ensure cluster reliability. Analyzer. You are advised to use at least 4 servers to form an analyzer cluster. Of these servers, one functions as the active management node, one functions as the standby management node, and the others function as the application nodes. The number of application nodes depends on the network management scale of the data center. Service functions of the analyzer cluster are deployed on multiple analyzer nodes. After services are started, the message bus periodically checks whether the services on each analyzer node are available. If a service is unavailable, the message bus reschedules the external access request. As long as one of the active and standby management nodes runs properly, the FabricInsight management plane can properly manage the analyzer cluster. The active and standby management nodes can exchange data with application nodes and dynamically schedule analysis services. Services of the analyzer cluster are not affected by SPOF. Server network ports are bonded and work in active-active mode. Collector. Each collector server requires 8 network ports. Each pair of ports are bonded or work in active-active mode based on the site requirements. To further improve reliability, ensure network ports that are bonded or working in active-active mode are on different network adapters, preventing services from being affected by network adapter faults. The bond and active-active mode of the collector network ports are described as follows. Bond, Ethernet 0, Ethernet 1. This bond is used to report data to the analyzer. Bond, Ethernet 2, Ethernet 3. In outbound management mode, this bond connects to the management switch to manage network devices in the data center. In inbound management mode, this bond is not configured and 2 network ports, Ethernet 4, Ethernet 6, work in active-active mode to manage network devices in the data center. Active-active mode, Ethernet 4, Ethernet 6. This group of network ports is used to collect data reported by switches in the data center. Active-active mode, Ethernet 5, Ethernet 7. This group of network ports is used to synchronize the PTP clock between collector clusters. Analyzer. The active and standby management nodes of the analyzer cluster require 4 Ethernet ports, and the application nodes require 2 network ports. Each pair of ports are bonded based on the site requirements. The bond of the analyzer network ports is described as follows. Bond, Ethernet 0, Ethernet 5. This bond is configured only on the active and standby management nodes and is used for external systems to access the analyzer cluster. Bond, Ethernet 1, Ethernet 7. This bond exists on the active and standby management nodes and application nodes and is used to receive data from the collector and is used for internal data communication between analyzer nodes. If a port in a port group is faulty, services carried on the port group are not affected. Configuring stack or MLAG for leaf switches. You are advised to connect the network ports of the collector cluster and analyzer cluster to the leaf switches of FabricInsight. At least 2 leaf switches are required for configuring stack or MLAG to ensure that services are not affected when a leaf switch is faulty. In addition, the bonds or active-active ports of both the collector cluster and analyzer cluster must be connected to a leaf switch. Advertising virtual IP routes between the collector cluster and leaf switches to implement the active-active mode. In the collector cluster, an OSPF neighbor relationship is established between the active-active Ethernet 4, Ethernet 6 network ports of each server and the leaf switch. In addition, a unified virtual IP (VIP) route is advertised to implement multi-active load balancing using the ECMP capability of network devices. When a collector server in the cluster is faulty, it stops sending OSPF heartbeat packets. After the heartbeat timeout period elapses, the leaf switch triggers route recalculation, and subsequent mirrored packets and performance metrics will not be sent to the collector server, implementing dynamic fault isolation.